In this video, I wanted to teach you how to take z-scores and figure out percentages from them using a z-table. And there are other ways to do this too, using other types of calculators, but essentially the idea of how this works is we're going to take our z-score and look up in a table, okay, what is the representative percentage behind that? So kind of summarizing the last couple videos, the idea of a z-score is we're normalizing a distribution to the same scale, where 0 means the center, 1 means 1 standard deviation to the right, and so forth. 2 means 2 standard deviations to the right. Now, the great thing about this is every standardized distribution is exactly the same. And we know exactly the percentages of a standardized normal distribution. All of those can be found within a z-table. So if you look at a z-table, let's go ahead and go to these table A from our textbook, which is in the slides. And if you actually just open to the very front of your textbook, let me grab it, show you where to find this. Should be somewhere in the first few pages. That's table C. Looks like table A was removed, but it should be at the very front of the book, but it's not. Maybe it's at the back. Yeah, it's at the back, sorry. But table A is right back here. Basically, any statistics textbook should have such a table. Most people just refer to them as z-tables, but I might call it table A sometimes just because that's what it is in our textbook. But essentially what this table does is it gives us what's called a cumulative proportion for every z distribution. So essentially when we're looking at the table, how we interpret is it's the percentage of the population that would fall to the left of that particular z-score. And now how you actually read the table is, notice that on the left-hand side, sorry, it's a little bit blurry on my screen, but notice that gives you the z-score of, say, let's say we had a z-score of negative 2.4 or negative 0.9 or something like that. Basically, we can read this as the row that we look at would have that particular value. And the top tells us with a little bit more detail of, well, what if it was negative 3.40? Basically, this would be our percentage of that in that particular z-score. Or let's say we had negative 3.41, negative 3.42. Basically, each entry in this table is related to a very specific z-score on the example. So let's actually return to the example from the previous video and let's look this up within our table. And actually what I'm going to do is I'm going to use ztable.com instead, because it's just easier to transition from there rather than to flip open the book and whatever. But again, you can use the one in our book, or you can just look it up online or print it out. But basically all z-tables should be exactly the same. And they should look in the same way. And we'll talk about normal proportions. We'll talk about this strategy in just a second. But let's return back to our original example where, whoops, I didn't mean to do that, where we had two women who were, one was 5'11" and one was 5'2". And we found their z-scores. But essentially, once we know a z-score, we can look up the respective cumulative proportion in the z-table. And again, I could kind of imagine this as, well, the girl who was 5'11" had a z-score of 3. That was far to the right, as it always will be on our scale. And essentially, by looking up the table, we're going to calculate the percent of women who are less than that score. Basically, if we go into the table, let's just find it. So first we need to find, well, where is z equal to 3, which is right here. And again, the first entry will be 3.00. So basically this number right here is going to be the proportion that we're looking for the particular z-score. So for a z-score of 3, we're going to get a cumulative proportion. I'll just go ahead and write this here. And why it's called this is basically we're adding up all the percentages for everyone less than that cumulative proportion. That's just what we mean by that term. And basically that cumulative proportion is 0.9987. So 0.9987. And what that means, and this number should not be surprising, because remember the area underneath the total curve should be 100%. And this is about 99.87%. This means almost all, like very, again, this is a percentage, 99.87%. But basically how we could interpret this information is, well, basically 99% of women are going to be shorter than 5'11". And again, we could sort of assess, well, do we think this is really valid by looking at that? I think this is not particularly correct, but again, we're just looking at these examples to practice using the math of the normal distribution. And again, assuming that data was correct, this would be, our conclusion. Because that's what a z-score of 3 means, is very, very extreme value. And now let's say we're looking at a woman who is 5'2". Her cumulative proportion, well, again, we'd look at her z-score, negative 1.5 would be about over here. And we'd expect this number to be much smaller. I'm guessing something like maybe 10% or whatever, but again, because the percentages should go from 0% all the way to 100% from left to right. And those cumulative proportions, if you're examining the table, notice they start very small and they get very big as we progress through the cumulative proportions. But if we wanted a z-score of negative 1.5, again, it's going to be the first entry. If you get, say, negative 1.57, then you just need to count over 5.1, 5.2, 5.3, and go all the way over here. But negative 1.5 exactly was going to be the first one, 0.0668. So the cumulative proportion here would be 0.068. I already forgot. 0.668. Which again in percentage form would be 6.68%. And again, the interpretation here is that 6.68% of women are going to be shorter than 5'2". So again, we see that since 5'11" is fairly extreme, pretty far above the average in terms of height, we have most women are going to be shorter than that. But with 5'2", only 6% of women are going to be shorter than that, because that's a kind of an extreme value on the other side. And this is the key to solving these sorts of questions. Now, question number 6 from the packet asks us, what percent of women fall between those scores? So this is kind of another thing where in order to fully solve, you first need to figure out what are the individual cumulative proportions of those z-scores, and then basically take the difference between them. But if we look at this, let's kind of focus on the step-by-step instructions from our textbook. It says step 1, state the problem in terms of the observed variable. Draw a picture that shows the proportion you want in terms of cumulative proportions. So looking at this very specific example, we want to know what percent of women fall between 5'2" and 5'11". And again, since we already calculated their z-scores, what I usually recommend doing first is, well, first figure out what are those z-scores for those two heights. And we already knew that from the previous couple examples. And we had a z-score of negative 1.5 and a z-score of 3. And of course, 0 is always in the middle, on the top of the bell curve. And then, what it says to do next. So this would be kind of our picture, which helps us imagine the situation. In step 2, it says standardize x, restate the problem in terms of the normal variable z. Well, we already did that. I actually recommend doing that before you draw the picture, but you can do it either way. And then step 3, it says use table A to find areas to the left of z. The fact that the total end of the area under the curve is 1 may also be necessary to find the required area. But basically, it sort of says to then figure out, well, what's the cumulative proportion? And basically, you're going to sometimes need to subtract either from one or from the other values. In the case of 2 z-scores, to find the area between, you always need to subtract the smaller from the larger. But that's simply because the total percent of women who are shorter than 5'11" is this. But what we're concerned about is we want specifically in between them. So if we took this whole cumulative proportion, sorry, let me do this in red, and we subtracted the percent of women who are shorter than 1.5. So essentially we don't want that part, because we specifically want the percent of women who are between those two. Basically, we would just take this score minus, or this proportion minus that proportion. And this would give us the area between. Because again, the z-table always gives you all the way to the left, and we don't always want all the way to the left. Sometimes we want in between. And the difference in their two cumulative proportions is going to give us the total. So if we go ahead and do that, basically, we're going to have, so sort of summarizing, to find the area, to find the cumulative proportion between two z-scores, step 1, convert them to z-scores. Step 2, look up the proportions in table A. And step 3, take the difference. So we'd have 0.9987 minus 0.0668. And if we went ahead and did that, 0.9987 minus 0.0668, this would leave us with 0.9319, or approximately 93.2% of women would be in between that height range. And we can get a sense of how, what proportion of our population fits a specific guideline. And I'm sure you guys can see the value of this for looking at any sort of statistical publications. Like if we're trying to publicize data, and all of this we can extract simply from knowing the mean and the standard deviation. Everything else kind of comes from there, and it's all relative. Again, assuming it is normally distributed.